We all know how to use battery, but how do batteries work? It all started with Alessandro Volta in the 1800s, the inventor of electrical battery or the voltaic cell, and it's also known as the galvanic cell. So let's begin with the basic concept of electrochemical cell. Electrochemical cell is a device that produces electrical energy from a chemical reaction or uses the electrical energy to force the chemical reaction to happen. Types of electrochemical cells: galvanic cells and electrolytic cells. Galvanic cells are electrochemical cells in which oxidation-reduction reactions occur spontaneously to produce energy. While in electrolytic cells, an external voltage is applied non-spontaneously to produce energy. So we're going to focus on galvanic or voltaic cells. So what's a galvanic cell? It's an electrochemical cell that converts the chemical energy of a spontaneous redox reaction into an electrical energy. So from a chemical reaction or redox reaction into electrical energy. So let's move to the major parts of any simple or basic galvanic cell. Cathode electrode, which is a metal where reduction reaction occurs. Anode electrode, which is also a metal where oxidation reaction occurs. Electrolyte, which is an aqueous or molten substance that conducts electricity. Salt bridge, which is used to complete the inner circuit and to maintain the electrical neutrality of the electrolytic solutions of the half cells. External circuits, which allows the electrons to move. So it's time to show you the major parts of any basic galvanic cell. So here we have two beakers of electrolytes, and I used zinc sulfate as a solution and the copper sulfate as a solution. And I put the copper electrode as the cathode and the zinc electrode as the anode. And I used the salt bridge to maintain the neutrality between the two solutions. And this wire is actually used to connect these two electrodes together. The zinc electrode represents the oxidation reaction, while the copper electrode represents the reduction reaction. So when we connect these two electrodes by this wire, something will start to happen. Electrons will start to move through this wire from the zinc electrode or the anode to the cathode. So we can see that moving electrons generate electricity. Now let's understand what causes these electrons to move from the anode to the cathode. This is a magnification of different parts of the galvanic cell. This is the zinc electrode, and this is the copper electrode. This is the edge of the zinc electrode with some zinc ions are dissolved in the solution, and the edge of the copper electrode with some copper ions are dissolved in the solution. Copper 2+ has a strong pull of electrons, while zinc 2+ has a weak pull of electrons. So what will happen here is copper 2+ is going to take electrons from the zinc, and the zinc is going to turn into zinc 2+, which has the ability to dissolve in the solution. So after turning into zinc 2+, this ion will dissolve in the solution. And one of these Cu2+ is going to take the two electrons from the anode and turn into Cu and form a precipitation around the copper electrode. This process of moving of electrons is going to continue to happen after we get a new shape of the two electrodes. So if this happens long enough, we will see these two metals change. zinc metal got smaller due to the loss of electrons, while copper metal got bigger due to the gaining of electrons or the precipitation around the copper metal. So this is a brief illustration of how a galvanic cell works.